All right, good afternoon, everybody. So, cosine law, the last little section here of our chapter. So, sine law is used for non-right angled triangles, and so is cosine law. So, they are both used for solving non-right angled triangles. All right, so if you don't have something that's 90 degrees in if none of the angles are 90 degrees, you don't have one that's 90, then that means that you do not have a right triangle, which means that to solve, get all the angles and all the sides, you may need to go with either cosine law or sine law. All right, now the difference between the two is that sine law, you needed to have a matching pair. You got to have an angle and an opposite side. For cosine law, you use this whenever you don't have that situation. So if you don't have an angle and an opposite side, then you need to use this method. All right, so here is cosine law as a formula. C squared equals A squared plus B squared minus 2AB cos C. All right, now that seems like a mouthful, and it is. And typically on a exam or a test, this is your standard cosine law formula that's given to you. All right, so let me just explain it to you. So C squared, so one of the sides is equal to A squared plus B squared, take away 2ABC, which is 2 times A times B times cos of the angle C. Okay, now you're going to use this if you have angle C. Now, side C is not opposite 90 degrees because there is no 90 degrees, nor does side C have to be the longest side. It doesn't. You have three sides. Whatever side C is, its squared is equal to A squared plus B squared minus 2 times A times B, the cos of that angle C. All right. Now, what if you don't have angle C? Let's say they label it, ABC, but they don't give you angle C. What if you have only angle B? Well, then what you need to do is you need to manipulate. You got to rearrange or figure out what the formula would be, not rearrange. Let me reword that. You need to come up with a new formula that looks like this formula, C squared equals A squared plus B squared minus 2AB cos C, but instead for side B with angle B in it. Do you think that you're able to do that? Are you able to come up with the formula for this equation? So I'll let you think about it for 1 minute. See if you can come up with, Okay, I'm not asking you to rearrange it. All right, so here is what hopefully you got. So B squared is going to then equal the sum of the other two sides, which are A and C, take away 2 times A times C cos B. All right, so there is the formula, and do you notice how it kind of looks like the cosine formula I gave you earlier? C squared equals A squared plus B squared minus 2AB cos C. If you have B squared or angle B, then you want the formula B squared equals A squared plus C squared, take away 2 times A times C cos B. All right, hopefully that's clear for you. All right, what if you have angle A? All right, so I've given you I gave you the original formula, and now I've given you this, how to come up with the formula for if you have angle B. What if you have angle A? All right, so now what you need to do is say, well, in that case, do you think you can do the rest of it? All right, if you got that, you did come up with the rest of it and you got it right. Okay, so A squared equals B squared plus C squared, take away 2 times B times C cos A. All right, let's do some For cosine law, you need 3 out of 6 pieces of the triangle. So there's 3 sides, there are 3 angles. You need to have 3 out of the 6. And then you can use either sine law or cosine law, depending on what you have. But for cosine law, you don't have a matching pair. In other words, you don't have an angle and an opposite side. All right, let's do an example. Here's example number 1. Okay. Do you see how we have 3 of the 6 pieces? There's 2 sides and there's 1 angle. And do you notice that we don't have a matching pair? Okay, we don't have an angle and an opposite side. 60 degrees, I don't have BC, right? I can't assume this is 90 degrees. I can't. I don't have a way of calculating that third side BC using Pythagorean theorem because I don't have a 90-degree angle, so I can't do that. I don't have the side opposite AB, which is 3 centimeters, little c in other words. I don't have angle C, and I don't have angle B, right? I have 4 centimeters for AC, or little b, but I don't have it. All right, I'm going to label now the sides in terms of the vertices, okay? So remember again that the vertices, the side opposite those vertices are little letters. So this is A, and the vertice B is on top, so this is B, and that's little c. All right, so now what you do is you say, all right, I need to figure this out. I got 3 of the 6. I'm going to do cosine law. I have angle A. So you need the formula with angle A in it. So in other words, A squared equals B squared plus C squared minus 2BC cos A. Now, I could say to you, and you may say, well, can't we just change the vertices around so that I memorize one formula and then I just work with it that way? You can, but unfortunately, if you start doing things like that, there's a higher risk of getting confused with what you're actually asked. If you're changing A, B, and C, and then they're asking for angle B, for example, and you relabeled it, it does require an extra step that you may miss if you've renamed everything and then you thought, oh, I've got the answer, but that's not what they're really asking for. All right, I think it's easier if you have the formula to come up with these other 2 equations. You will be given typically one of the cosine formula. All right, it's either A squared equals B squared plus C squared minus 2BC cos A. Usually it's in the form of C squared equals A squared plus B squared minus 2AB cos A. Cos C. All right. All right, so now let's plug in what we know. So we don't have A, right? So I'm going to match up the letters. So I got A squared equals B is 4, so 4 squared, plus C is 3, so 3 squared, minus 2, and I'm going to put this in brackets. B is 4, C is 3, cos 60 degrees. All right. So let's go ahead and do this. This is 16, this is 9, this is now, you got to be really careful with this because there's an order of operations thing going on here. So 2 times 4 times 3 is 24, and then cos 60 degrees, all right? So I'm just going to finish this up, right? I have to do the multiplication. There's a multiplication right here. So 24 times cos of 60 degrees. So you need cos 60 times 24, and I get 12. So it's 16 plus 9, 25 take away 12, which is 13. And what we need to do is find A, so we take the square root of both sides. A then equals plus or minus the square root of 13. We ignore the negative because it is a length. We're not like with the unit circle. We're not on a coordinate axis. This is just a triangle. So therefore, the length is positive. It would then be the square root of 13 centimeters. All right, and that would be the exact value. If the question asked you for exact value, it's the square root of 13. If they asked you for to 1 decimal place, then you would need to put it into a calculator and take the square root of 13 and answer to 1 decimal place. We'll leave it as root 13 for now. All right, because you can always plug it into a calculator if you had to. Here is example number 2. All right, so do you notice again in this question, we have 3 out of 6 pieces. We have 3 sides, but we don't have any angles. And if you're asked to find, oh, let me go back to you to this question. Sorry. All right, what was they asked here? Okay, there was actually no question. If you're asked to solve this triangle, now that you have this is the square root of 13, now we have a matching pair. You could then use sine law to find angle B or C. All right, so is that clear? Now that we have this angle and now we've just calculated this side, we now have a matching pair. You could then turn around and you can calculate angle B and then turn around and calculate angle C, right? So, or go ahead and calculate angle C first and then using sine law, right? And then once you've done that, then you can add the 3 angles. They got to add up to 180. Take the sum of A and C here from 180 and you would get angle B. All right, so if it's okay with you, I'm not going to continue on with solving all the pieces in here, but if you were asked to do so, just know that you'd be better off switching over to sine law at this point. All right. Example number 2, same idea. We're gonna, if we're asked to calculate all the angles here inside here, we can. We'd start off with trying to find one angle. All right, we have 3 sides. We don't have a matching pair. We have to go sine law. All right, there's 3 angles. You have no information on either one of them, so you just need to find out the angle, one of the angles. So you would do that with cosine law. You can pick whatever side you like. I'm going to choose B. All right, so just because. And here we go. So here's the formula for cosine law. All right, B squared equals A squared plus C squared minus 2AC cos B. All right, so let's label our sides. So it's a good thing to do that. Then you're not guessing, you know, where is everything. So I'm going to label that. All right, so we have B here, which is 40 squared, equals A, which is 23 squared, plus C is 26 squared, minus 2 times 23 times 26 cos B. All right, so be very careful of order of operations here, and I'll show you what I mean. So 40 squared is 1600. 23 squared $529. 26 squared, 676. Take away 2 times 23 times 26 cos B. All right. So now what we have is we can figure out, I'm just going to continue again. So 2 times 23 times 26 minus 1196 cos B. All right, here is where it's super, super important that you understand this. Okay, you see this 1196 cos B? That means we have a value 1196 times cos B. So if we compared it with 1196 times x, if that was the case, notice to get x, in this case, to get cos B, I cannot do 529 plus 676, take away 1196. I cannot do that calculation because the 1196 is the number times cos B. All right, so once again, this 1196, the most common mistake I see with cosine laws is right here, people decide to go 529 plus 676 and they take away 1196 and they get a value times cos B, and then they divide both sides by that number. Do not do that. The 1196 is with cos B. It is times cos B, just like 1196x. You need to get rid of these pieces over here to bring it over there. All right, so 529 plus 676. Let's do that. 529 plus 676. I got 1205. Okay, 1600 equals 1205 minus 1196 cos B. So again, the 1196 is with cos B. Do not subtract it away from 1205. Instead, what you must do is get rid of the 1205. So I'm going to subtract 1205 on both sides. So 1600 minus 1205, 395. So I get 395 here now is equal to negative 1196 cos B. Okay. Please make sure that you understand the importance here of keeping the value in front of cos B together with cos B. All right. Do not, please, do not just add or subtract it. Because to get rid of it here, we must divide both sides by 1196. Okay, is that clear? All right, and we'll go over here. So cos B then is equal to 395 divided by negative 1196, which is negative 0.3302. Well, we'll round up. All right. Now, you're not asked to find the ratio, you're asked to find the angle here, so we need cos to the minus 1 of this value, negative 0.3303. So I'm going to go second function, cos to the minus 1 of the answer, and I get 71 degrees, 70.7. I'll round off to 1 degree. We typically round off to the whole, so I'll just do the whole. Sometimes it's one decimal place. All right, so now we know that angle B is 71 degrees. All right, and if you kept it as 70.7, that's fine as well. Okay, but I'm gonna round off. Let's say 71. Now notice that we have again a matching pair. We have an angle and an opposite side. Okay, so we have an angle now, an opposite side. We can then, using sine law, pick either side A or side C, go calculate angle A. Once you've done that, you've got 2 of the 3 angles. You figure out the third angle by subtracting it from 180, and you're done. All right, all good? Your homework is page 119. These questions for next Tuesday. All right, have a good long weekend. It's supposed to be beautiful this weekend. Please enjoy the weather. Supposedly 28 degrees, and again, make sure that, well, it's Mother's Day too on Sunday, so thank your mom for putting up with you, and yeah, hope you have a good weekend. Take care, guys. Bye-bye now.